Hello, everybody. Today is going to be a video lesson for Tuesday, October 20th, and we are looking at our day 4 topic, which is slope-intercept form. This is a huge topic for algebra, just in general. Slope-intercept form is the most common form of linear equations, especially when we're graphing them. It's the most useful, the easiest way to do this is to use slope-intercept method of graphing, and that's what we're going to look at today in our lesson. So our learning targets today, we have two of them. I can identify the slope and the y-intercept from an equation, and we're also going to then look at graphing an equation when it's written in slope-intercept form. So a couple of reminders from last week. Item number 1 is just a reminder about the Unit 1, Day 3 homework assignment from earlier last week. And then on Wednesday for class, you were instructed to take quiz 1A. So if you did not do that on Wednesday, I did go ahead and open that back up. I believe it was Friday. So you can go back and complete that at any time. Please make sure that you do that to get your quiz points. Let me know if you have any questions or you're having any troubles with that. All right, so you're going to want to pause the video here in just a moment and set up your Cornell notes. Remember, your notes are what you're allowed to use while you are testing on the unit test. So today's topic is slope-intercept form. It's day 4. And our question for today, how do I graph an equation in slope-intercept form? So go ahead, pause the video and play when you're ready. All right, so first we're going to do just a real quick warm up. You can do this on your head or jot things down on your notes, but I just want you to find the slope. So please pause the video and resume when you are ready. So a reminder that finding the slope, we want to use the slope formula. However, we can kind of use the shortcut slope formula, that it's just rise over run. So on our graph, we just have to figure out the value of the rise and the value of the run. Now, there's two different ways we could calculate that for this particular graph. If I start on the ordered pair on the left, I guess it's -2, 4. My rise is actually going to be if I go down, because I want to get to that other point over here at 2, 1. So I'd have to go down first, and then I go over to the right. Now, I went down 3. But because I'm going down, think about the rise. Rise typically means to go up, so that would be a positive rise. But when I go down, that actually makes it a negative rise, a negative value here. The run, I'm going from left to right. And as I count here, it's 1, 2, 3, 4 units. And because I'm going to the right-hand side, think about the x-axis here, to the right is positive values. I know that my run is +4. So one way to write this slope is to write it as the ratio where the rise is -3 and the run is +4, which -3 divided by +4 would just reduce to a -3/4. Now another way to look at this is, what if we started at 2, 1? And I wanted to go to the other point. I kind of wanted to go up and to the left instead. I always do my rise first, so I have to go up, and then I can go to the left to get to my other point. That will also help calculate my slope. So if I do that, if I'm starting at 2, 1, and I go up 3 units, going up is a positive rise. However, when I'm going to the left 4 units to complete the run there, because I'm going to the left, think about the x-axis, to the left is negative numbers, smaller values. That means that my run would be -4 this time. So if I want to look at my slope as the ratio of those two values, I'd have my rise, which was +3, over my run, which was -4. And anytime I am dividing a positive and a negative number in any order, I know that I have a negative overall value. So either way, you have the exact same slope of the line. It is a -3/4. I also want you to know this as we look at our graph over here. Take a look at the direction that the line is going from left to right. So starting on the left-hand side, my line is falling. It is going downward. And as we saw last week, or even the week before that, in our lesson for slope, we saw that any time that you are going down, like the little skier, we would have a negative type of slope. And anytime you have a negative type of slope, you must have a negative value for slope, which we have. All right, let's take a look at the first section of today's notes. So what we have here is we have three forms of a linear equation. You don't need to write all of this down. I really am just focusing on this first circle. Slope-intercept form is one way that we write linear equations. And typically we think of that as just y equals mx plus b, where m is the slope and b is the y-intercept. And I actually have this on a separate page for you to write down. Point slope form is a little bit different. That's when you're given slope, again, which is m, and you have an ordered pair, like a point on the line that you know of, not necessarily the y-intercept, but some other random point. And then our third form here is standard form. That's what we talked about last week in our day 3 lesson. And that's where we would do the cover-up method to find the two intercepts, and then graph using standard form, or intercept method. So today we're going to focus on slope-intercept form instead. All right, so here's for our notes. So what is the slope-intercept form of an equation? Or you could just write slope-intercept form on the left-hand side. And on the right-hand side, please copy down y equals m times x plus b, just like this. Typically, we just say mx plus b. You will want to note that m, so this variable here, excuse me, this letter, this constant, is the slope, and the letter b then represents the value of the y-intercept. In other words, where does your line that you're graphing, cross the y-axis, okay, that vertical axis. So what we're going to do, and feel free to pause it if you need more time to copy things down, but we're going to go through some examples, and we're just going to work on identifying, okay, so what number is the slope and what number is the y-intercept on several examples. So let's start here. Number 1, identify the slope and y-intercept from each equation. We have y equals 2x minus 3, and notice if we look at our original example up here where m is, it's that number that's right in front of the x. You could call it the coefficient of x. Or sometimes we just say it's the number that's being multiplied by x. And in this case, that's going to be the number 2. So the slope of the line is 2, or if we want to think of it for graphing purposes, we can say it's 2 over 1, because any number can be turned into a fraction if we just put a 1 underneath it. So then the y-intercept is the value that's being added at the end. In our form up above, it just says plus b, which represents the y-intercept. And in this case, it's going to be the minus 3, or negative 3. So keep in mind, this equation doesn't have addition in it, but we could rewrite this so it does. So instead of saying 2 times x minus 3, we can think of it as y equals 2x plus negative 3, because we know that adding a negative value is the same as subtracting a positive value. So that's why our y-intercept is a negative 3 and not a positive 3. Let's look at number 2. All right, for number 2, we have y equals 5 plus negative 1/3 x. And don't be fooled on this one. Notice that the x is in a slightly different location. It's not y equals something x plus another number. The x is kind of at the end. So what we want to do is, keep in mind, you can rearrange terms in an equation as long as you're keeping the signs correct, that we can switch these around. Basically just do a flip and say it's y equals negative 1/3 x, and then we put the plus 5 at the end. This helps us see that the slope of the line, again, that's the number that's being multiplied by x, is negative 1/3, and the y-intercept, which is the value being added at the end, is positive 5. So the slope is negative 1/3, and the y-intercept is positive 5, or the point 0, 5. All right, we're going to go on to the next page. Feel free to pause if you need time to copy those down. All right, for number 3, we have y equals x. Now, on this one, we don't see any numbers at all. However, there are 2 numbers there. They're kind of hidden invisible numbers, and they're actually different values. So if we want to try to rewrite this using values, y equals something times x plus something, let's think about what numbers could we put in those blanks to make it simplified to just be y equals x. So in the first blank, we want to think about what number is multiplied by x to just get x. Well, something times x to keep it the same, that number has to be 1, since 1 times x is just x. Now for the y-intercept, it wouldn't be 1 in the blank. It's not just always if you don't see the number, it's 1. Because think about what number can I add to x to keep it x? In other words, what do I add to something to not change it? And it has to be then the number 0, because anything plus 0 is itself. So in this case, the slope is just 1, or for graphing purposes, we can call it 1 over 1, and the y-intercept is at 0. For number 4, this equation is actually written in point-slope form. It's completely different than what we're used to seeing. It's not even like just a y equals equation. So before we can tell what the slope and the y-intercept are here, we want to do a little rewriting of the equation. So we're going to start by distributing the right-hand side. And this is something you're going to learn in a future lesson. We're going to distribute. We get y plus 8 equals, and we distribute the negative 3, so we get negative 3x. And then when we distribute, remember you're multiplying a negative 3 times a negative 5 gives you a positive value, positive 15. Okay, so that's step 1, is distribute the right-hand side. Step 2, we want to get y by itself. Okay, this is just like solving literal equations. I just want to solve for y and get it by itself. So if I want to undo the plus 8, I subtract 8 on each side. And let's see, what would I subtract 8 from? Well, 8's just a number, so I subtract it from the other number. And that's going to leave me with y equals, because that's going to cancel. I bring down the negative 3x, and then I do 15 minus 8, which is positive 7. So looking at my equation, I can see that my slope, again, that's the number right in front of the x, it's that coefficient, is negative 3. Or, again, for graphing purposes, we can think of that as negative 3 over 1. And then my y-intercept is just positive 7. Number 5. This time we just have the equation y equals 6. Let's see. Y equals something x plus something. Okay, so I got to think about what number do we multiply by the x here to make it. Oh, wait a minute, there's not even an x in the equation. So what do I multiply by x to make it go away? So if I multiply it by 1 times x is still x. So in this case, I think I actually have to multiply it by 0. Because then 0 times x is 0. And I have to figure out, well, what is the y-intercept? What is this number over here? So that when I add all this together, I get 6. Well, it's got to be itself. It's got to be 6. Because 0 times x is 0, and 0 plus 6 is 6. So simplified, it says y equals 6, but unsimplified, the slope is 0, or for graphing purposes, we can think of it as 0 over 1, and the y-intercept is positive 6. All right, last one, number 6. We have x equals negative 2. And this one is actually kind of a trick question, because if we want to try to get our equation to read y equals something times x plus something, like we've kind of been filling in on the other ones, we're going to have a little bit of a problem there because we don't even have a y in the equation. There is no y. It's like being 0y. So the trick here is that we actually don't have a y-intercept. So we're just going to say not applicable, or NA. And the slope on this one is that one slope that we talked about a few weeks ago, where it's not a number. Okay, there's no value to it. It's not that there's no slope. Okay, that's different. That's a slope of 0, like problem number 5 here. This type of problem is an undefined slope. That's the line that would give us a perfectly straight up and down vertical line. Okay, and I know it can be a little tricky. So if it's just x equals a number, any number, the slope is undefined, and there actually isn't even a y-intercept involved. All right, feel free to pause if you need more time to copy those down.